Hi, Algebra 2. This is Unit 10, Lesson 11, and today we're going to talk about the Remainder Theorem. So in the last lesson, we talked about division, polynomial division, and in this case, we're going to do the same thing. We'll do it with long division, we'll do it with synthetic division, and we're going to get a remainder, though, each time. All right, so let's do long division. So I have x minus 2 and x squared minus 8x plus 18. All right, so x goes into x squared x times, and then I just multiply the x times this x minus 2 out here, and that gives me x squared minus 2x. Then I'm subtracting this whole thing, so the x squareds cancel out. Negative 8x minus negative 2x is negative 6x, and then I bring down the 18. And then x goes into negative 6x, negative 6 times. Negative 6 times x is negative 6x. Negative 6 times negative 2 is positive 12. But again, remember, you're subtracting this because you want those x's to, the negative 6x minus negative 6x cancels. 18 minus 12 is 6. So that's basically my remainder. My remainder is 6. Now look what happens if I evaluate p of x. So p of x is x squared minus 8x plus 18, and I'm going to evaluate p of 2, which so happens to also be this number right there. So if I evaluate 2, I'm doing 2 squared minus 8 times 2 plus 18. So 2 squared is 4 minus 16 plus 18. 4 minus 16 is negative 12. Negative 12 plus 18 is 6. Well, look at that. When I evaluate it, it's the same thing as the remainder. All right, so that's what we're going to see. Let's do it one more time. And then we'll try it with synthetic division as well. So I'm taking x squared minus 2x minus 25, and I'm dividing by x minus 7. So x goes into x squared x times. X times x is x squared. X times negative 7 is negative 7x. But then I need to subtract that. Negative 2x minus negative 7x is 5x. Bring down the negative 25. X goes into 5x 5 times. 5 times x is 5x. 5 times negative 7 is negative 35. But of course I'm subtracting that. So negative 25 minus negative 35 is 10. All right, same thing. I want to evaluate p of 7. All right, so 7 squared minus 2 times 7 minus 25. 7 squared is 49 minus 14 minus 25. So 49 minus 14 is 35. 35 minus 25 is 10. Well, look at that. The answer when I evaluate p of 7 is the same as the remainder that I get. Okay, interesting. Let's look at these when I'm going to use synthetic division, just to remind us how to use synthetic division. So basically, I'm going to do negative 3 out here. And again, that negative 3 is coming from this right there. All right, and I'm just taking the coefficients. So 2, 11, and 11. So remember, I bring down that 2. Negative 3 times 2 is negative 6. I combine 11 and negative 6 is 5. So I multiply negative 3 times 5 is negative 15. And then I combine, and that's negative 4. So basically, my answer is 2x plus 5, and negative 4 is my remainder. Negative 4 over x plus 3. Okay, so that's my answer when I'm dividing. Again, they want me to evaluate that p of negative 3. Okay, so 2 times negative 3 squared plus 11 times negative 3 plus 11. So that's 9 times 2 is 18, negative 33. 18 plus negative 33 plus 11 is negative 4. Okay, so when I evaluate it, it's the same thing as my remainder was. All right, do one more synthetic division. So negative 4, Remember, the coefficients are just written 3, 7, negative 20. So I start by bringing down the 3, then I multiply. Negative 4 times 3 is negative 12. 7 and negative 12 is negative 5. Negative 4 times negative 5 is 20. And negative 20 and 20 is 0. So this right here is the remainder. And I take those other coefficients and I write them with, I put the x's back in there. So remember, I was starting with x squared, so this is 3x minus 5. My answer is always going to be one level down. So 3x minus 5 is my answer. I don't have a remainder. Well, if I don't have a remainder, when I evaluate p of negative 4, which again comes from that, let's see what happens. So 3 times negative 4 squared plus 7 times negative 4 minus 20. Well, negative 4 squared is 16, and 3 times 16 is 48. 2 times negative 4 is 28, and it's negative 28, and negative 20. So 48 minus 20 is 20, and 20 minus 20 is 0. Well, look at that. I didn't have a remainder, and when I evaluate p of negative 4, I get 0. All right, let's flip this over. So here's my rule, the remainder theorem. Basically, the remainder theorem says when a polynomial p of x is divided by a linear factor, x minus a, then the remainder will always be p of a. So in other words, so they write p of x, okay, and I'm dividing it by x minus a. You're going to get some answer, some quotient, and then the remainder is just going to be p of a. So the remainder theorem is the primary justification for telling if a linear expression is a factor of a polynomial. How can we tell if a linear expression is a factor? If you evaluate p of a and you get 0, then that means that must have been a factor. All right? So let's look. If the ratio x squared minus 11x plus 22 over x minus 9, so a ratio is just a comparison of two numbers, it's just division, was placed in the form, some answer you get when you divided it, plus some remainder over x minus 9, where q of x is a linear function, then which of the following is the value of r? So normally, you would have had to divide this and seen what the remainder is, but I don't need to do that anymore because I can just evaluate 9. So basically, I am just going to evaluate, my a is my 9, I'm going to plug in 9. So it's just going to be 9 squared minus 11 times 9 plus 22. 9 squared is 81 minus 99 plus 22 equals 4. That's my remainder. Right? So you don't have to actually do the division if all they're asking you for is the remainder. All right, exercise 4. By the definition, x minus a is a factor of p of x if p of x over x minus a equals q of x, where q of x is another polynomial. What must be true of the remainder p of a for x minus a to be a factor of p of x? So basically, this is like our last problem right here, when I got a remainder of 0. P of negative 4 was 0. Okay, so for x minus a to be a factor, the remainder of p of a must equal 0. All right, so let's determine in exercise 5 if each of the following are factors of the listed polynomials by evaluating the polynomials. So if is x minus 3 a factor? Well, I'm going to have to evaluate 3. Remember, I'm doing the opposite signs. So 3 squared minus 11 times 3 plus 24. If I evaluate p of 3 and I get 0, it's a factor. So if p of 3 equals 0, then yes, it's a factor. So that's what I'm testing out. So 3 squared is 9 minus 33 plus 24. Well, that's negative 24 plus 24 equals 0. So yes, It is a factor. Is x plus 5 a factor? All right, well, I'm going to have to, so basically I'm evaluating p of negative 5. So 2 times negative 5 squared plus 9 times negative 5 minus 2. Well, negative 5 squared is 25. 9 times negative 5 is negative 45. So that's 50 plus negative 45 minus 2 is 3. So no, it is not a factor. Okay, so I can easily see if something's a factor by just evaluating p of a. So here I'm going to evaluate p of negative 1. So I have negative 1 to the third power minus 7 times negative 1 squared minus 11 times negative 1 minus 3. Well, negative 1 to the third power is still going to stay negative 1. Negative 1 squared is 1, but it's 1 times negative 7. Negative 11 times negative 1 is positive 11. And I'm going to have to work from the left to the right. Negative 1 minus 7 is negative 8. Negative 8 plus 11 is 3. And 3 minus 3 is 0. So yes, this is a factor. Okay, hopefully you're getting the idea right now. And I want to know if x minus 5 is a factor in this last one. So I'm going to evaluate p of 5. 5 to the third power minus 5 squared minus 19 times 5 minus 10. 5 to the third power is 125 minus 5 squared is 25. Negative 19 times 5 is negative 95. 125 minus 25 is 100. 100 minus 95 is 5, and 5 minus 10 is negative 5. So no, it is not a factor. Okay, and that's it for today.